Okay, in this problem, we want to find the volume of a pyramid. And all they do is they give you the height, which is 96 meters. So I drew a pyramid with a height of 96 meters in a square base. It's got a square base that's 150 meters. So each side is 150 and it's a square. So how do we find the area of a pyramid? Well, what we could do is use integration and find the volume of a pyramid. We could find the area of we could take slices. We could take a bunch of slices of this pyramid and then add them all up together to get the volume, right? Like think of it as like pieces of bread, but as you go up, they get smaller and smaller, right? In each side of this particular slice, we're going to call it S. In S, each slice has a thickness of delta y. We consider this the y-axis. So we have a delta y thickness and the sides are S. So remember, to find the area, the volume, you integrate the area. Okay? So what's the area of a slice that's S by S? It's S squared. Right? So what's the deal here? We can't just use S's. We have to get S in terms of Y. We're going to have to get S as some kind of a expression that has Y's in it. So remember, the area is the area of a particular slice, a face of a slice, and dy is the thickness of the slice. So let's see. What we can do to try to figure this out is we could cut the pyramid vertically. If you cut it down the side, you end up seeing a triangle. Okay? You see a triangle, and let's see, well, the bottom of the triangle is 150, right? Here's where your S is. Here's S. That's where your slice is. Okay, you know that it goes up to 96 up there. Okay, now we're going to make some assumptions. We're going to say we're going to call this distance from here to here y. So this distance has to be 96 minus y because the whole distance is 96. So if we're calling this distance y, this distance has to be 96 minus y. So I don't know if you can see it, but we actually have two triangles. We have the big triangle and we have this little triangle on top. So I think what we can do is we can use proportions. We can use the fact that they're similar triangles, set up some proportions, and get S in terms of y. That's what we're doing. Okay, so, all right. So this, I can write it over here, the small triangle. What is a small triangle? It looks like this. We don't know what this is, but from here to here, it's 96 minus y. And the big triangle goes like this. And we know that the big triangle, this is 150. And from here to here, it's 96. Right? So I think we can set up some proportions because they are similar triangles. They share the same angles, right? So let's see. I think what I did is I went S is to 150. So S is to 150. That the height of that one, 96 minus y, is the height of the big one. Right? So I just use S to 150, this to that. Okay? And look, what you can do now is you can cross multiply and solve for x. So if I cross multiply, I get 96s is equal to 150 times 96 minus y. So I just cross multiply, right? And I end up solving for x, getting x all by itself on one side. You end up getting s is equal to 150 over 96 times that, 96 minus y. So look at that. I got s in terms of y. So now, what does that mean? We got s. Can we find the area? The area of a particular slice is equal to s squared, which is equal to that thing squared, right? So I think I reduced this fraction and I got 25 over 16, 96 minus y, the whole thing squared, right? So that's our area. So now we can just do our integration, right? So our integration, we know the volume is equal, we're going y from 0 to 96. This is the area, right? So it's 25 over 16, 96 minus y squared dy. Okay. So then what did I do? I took this out, I squared it and put it out in front of the integration. So it's 25 over 16 squared, right? So what do I got left inside? I got 96 minus y squared dy. Makes it a little cleaner looking. So then I FOILed it, okay? So I FOILed it, so I still got the 25 over the 16 squared in front. This is from 0 to 96, so it didn't change. 0 to 96, I FOILed that, and I got 96 squared minus 192y plus y squared dy. Okay. Then I did my antiderivatives. So I still got the 25 over 16 squared in front, right? So to take the antiderivative of 96 squared, that would just be 96 y, right? Minus, you still got the 192, but you have to do 1/2 y squared to take the antiderivative of y, plus y cubed over 3, right? I'm just taking antiderivatives, and that all goes between 0 and 96, right? Okay, plug in time. So I still have the 25 over 16 squared. There's lots of areas where you can make a mistake. so it's 96 times 96. I'm plugging in a 96 for y, minus 192 over 2, 96 squared, plus 96 cubed over 3, minus, I can just put this big fat 0 in for the second thing, right? Because once you put 0 in, all the terms are 0. Okay, so what did I end up getting? Oh. So I still have don't forget this 25 over 16 squared on the front, because I would tend to do that. I got 8,884,736 minus 884,736 plus 294,912. Oh, that works out. Those cancel out. And then when I do the squaring and the division and everything, I end up with a nice round 720. What does that represent? The volume of the pyramid, so it's in meters cubed. Okay, so that was quite a problem, because first you had to visualize the slices, and you know that they're an area of s squared with a thickness of delta y. Then you had to get s in terms of y by using similar triangles. Then once you did that, you could plug it into the volume formula where you integrate the area dy, and then put all the numbers in, and you come out with a number. So I hope that helps. I'm sorry that was long. Okay, good luck, and hopefully it works out for you.